Assalamualaikum warahmatullahi wabarakatuh, and very good day. So as I mentioned earlier in the class, I would like to provide you a tutorial video on how can we solve fastener stiffness that includes bolt stiffness and also the clamp members. So soalan yang kita bincang tadi adalah problem 8.20 in our lecture slide. So before we start, let's read the question again. A 30 mm thick AISI 1020 steel plate is sandwiched between two plates. So sandwich meaning they have three plates all together. Two plates on aluminium and one plate on 1020 steel. And then compress with a bowl and nuts with no washers. So the bowl is M10 times 1.5, property class 5.8. Okay, so the question is A, determine the suitable length for the bolt rounded up to the nearest 5 mm. Second one, B, is determine the bolt stiffness, and C is on determine the stiffness of the members. So question A is very straightforward. I believe everybody know about this. So you just have to refer to table A31, and then you may see that the nut height and also the clamp members. So clamp members 10 mm, right, plus 10 mm of aluminium, and then 30 mm of the steel, and then another 20 mm of the aluminium, and then plus the nut height 8.4 mm. So 8.4 mm. So overall you get exactly the value of 68.4 mm. Okay, now you can either do two things. You can straight round up to 70 mm, or you can add 5 mm also possible. So whenever you add 5 mm, then it becomes 73.4. Then you can easily get, and then you round up to become 75 mm. Also acceptable, both of them. I know in the answer script in the slides they only mention to 70 mm, but both are acceptable. Okay, alright, so A is done. How about B? So B is also quite straightforward as well, similar to the previous example that we did together. Okay, so determine bolt stiffness. Bolt, you can either refer to table 8.7, kan? Table 8.7 bawah tu ada tulis fastener stiffness. Okay, so KB, AT and E. AD is area of the unthreaded area, AT is area of threaded area times young modulus of the bolt, and then AD LD. Okay, now your job is to figure out what is AD, what is AT, what is E. Okay, so now E, is it given in the questions or not? Tak bagi kan, tak bagi dalam soalan. Dia bagi tahu kepada kita bolt M10 times 1.5 saja. So nak pakai apa? So you boleh refer ke dalam textbook 8.8. Dan kita biasanya kalau untuk bolt ni dia adalah steel lah, steel. So E for steel is young modulus for steel adalah, ataupun young modulus, modulus elasticity, modulus elastic, all of them are the same. So 207 gigapascal. LT, LD, yes, you figure out. So refer to table 8.7. Then you can get all the values that required for all of them. Okay, and then finally you can get the final answer lah. KB is equal to PEP meganewton over meter. Okay, now moving on to question C. Determine the stiffness of the members. So tadi kita calculate stiffness untuk bowl saja kan, dan kita hanya pakai Young modulus untuk bowl. Sekarang ni kita ada Young modulus untuk steel, and also Young modulus for aluminium. Okay, so what to do? Okay, this is quite a tricky question. Okay, so let's do this together. What you can do, you can draw. Okay, you have a bolt here. 3 layer of component ataupun plate. So this is aluminium, and then this is what? The steel. Then given in the question, specific thickness of the plate for first layer of aluminium is 10, so you need mm, 10, 30 mm, right, for the steel, and this one is 20 mm. Okay, alright, so knowing this, what should we do to make it as in the conical shape for the analysis of the member stiffness? Okay, apa yang kita kena buat mula-mula adalah kita kena cari midline ataupun garis tengah di antara bowl, sini kan bowl atas ni kan, sini adalah nuts. So garis tengah antara kedua-duanya. So definitely we have 60 overall. You just divide it by 2, then you can have, this is 30, and then here also 30 mm, right? So to start the conical shape, what you have to know first is this is D, right? So D is 10 mm. Okay, as I mentioned earlier in the class, we have to know, after D we have to know the washer. I know there is no washer in this problem because it mentioned in the questions that no washer included, but to calculate a conical shape for the frustum, we have to have imaginary washer diameter. Here, dW. D washer usually is 1.5 D, so it's become 15 mm. Similar, we put to the bottom, dW. Okay, now what's next? So this is the middle of, okay, this is the midline of the bowl, and then we know that from the top it has to be 30, right? Dengan that conical shape dia kena macam ni eh. So here is alpha, which is 30 degree, because this is 90 degrees. So 180 minus 90 plus 30, kan segitiga kan adalah 180 degree kan? So 60. So here it has to be 60 degree. You have to make a straight line, and then because we want to have the projection line from here, and then you go straight. Okay, then you can have a touch point ataupun the midpoint tiga tu dengan garis tengah, and then actually it's symmetrical to the bottom line. Okay, now we have the conical shape of the three plates involved: upper frustum and lower frustum. Then we will have different thickness of the plates for the upper and lower. Okay, alright. So to calculate the member stiffness, what is the equation for the member stiffness? The equation is from the equation of 8.20 in the textbook. So the equation says KB, oh sorry, no, K. I think I want to use purple. K is equal to 0.57. So what is actually capital D, the uppercase D, and then small d? What is D and what is small d? Okay, so we have to understand this equation first. So D is actually the bowl diameter, that is 10 mm, betul tak? Maintain je bowl diameter, tapi D berubah-ubah. Okay, so ingat bila kita buat calculation ini, calculation kita adalah disebabkan oleh force ataupun load daripada bowl head dan juga nut. Maksudnya apa? Maksudnya sini ada bowl yang load. Maksudnya bowl tu memberi load kepada clamp members. Bawah ni pula ada nut. Nut juga memberi load kepada clamp members. So maksudnya dia akan bagi clamp. Kedua-duanya akan bagi load kepada clamp members. Dekat mana dia bagi load tu? Dan diukurkan stiffness tu dekat mana? Dekat surface dia. Maksudnya apa? Surface nya kalau contohnya daripada bowl dekat atas ni. Pada yang ni pula dekat atas ni. Okay. Yang bawah ni pula, that one is for upper frustum. For the lower frustum, at the bottom or bottom surface, and also at the second bottom surface. So meaning dia akan calculation kita adalah ke atas sini, sini, sini dan sini. Okay, baru kita nampak kan. So meaning dalam calculation ni D yang kita nak cari adalah D mana? D sini. So DW yang ni, D ini. Ni adalah D. Okay, untuk surface ni lah. Untuk surface ni pula, ini adalah D. Untuk surface, that one is both of them for the upper frustum. For the lower frustum, kat mana D dia? First D adalah sini. Kan? Second D adalah sini. Okay, you get it? So we have to have at least 4 expression or calculation. Sini 1, 2, 3, 4. Meaning ada 4K. Now let's move on. We calculate for this one. Lagi ke bawah. Okay. And then what is D in this one? Definitely D untuk this surface adalah equal to D untuk washer, which is 15 mm. Small d exactly the same. Semua ni D, ni D sama je. Small d. D is 10 mm. How about the thickness? Mengikut kepada size dalam frustum. So frustum untuk upper for aluminium is 10 mm. So how about yang modulus? Yang modulus for aluminium is, kita boleh refer kepada table 8.8. Okay, so is 71 GPa. Okay, what else do we need for this equation? I think that's enough. So you can calculate for K aluminium upper frustum. Boleh tulis macam ni so that you will not get confused lah. So K 0.5774. So times 71 GPa, and then D diameternya adalah diameter, small diameter, maksudnya bowl diameter 10 mm. So I maintain the unit so that whenever you tekan calculator nanti, make sure you calculate based on, I recommend to change everything to the SI unit, which is meter, okay, because gigapascal also reflect to the meter. Okay, load 1.15 15 minus 10. Okay, you press the calculator, you should get the same answer, 1.5. Okay, I know in the calculation in the lecture slide, this one they put 10.3. okay, this is wrong, sorry guys. So you just use 10 mm. okay, be careful. Okay, now we have finished this one for the first layer, layer pertama. How about the second layer? Okay, we have finished the first layer. How about the second layer? Now we want to move on to the second layer, which is here for the upper frustum. Okay, ni yang tadi, jangan confuse pula. Now kita pergi yang kedua, iaitu di sini. Okay, upper frustum. So this is we calculate now for the steel at upper frustum. Tadi tu adalah aluminium at the upper frustum kan. So now steel at the upper frustum. So what is D? Definitely the same, 10 mm. How about D? Confused. We don't know. D is, you can calculate based on this shape, the trapezoid shape. So this trapezoid shape, actually from what color that I still didn't use. Okay, so you can take from here to here. Now you have this part as 15 mm, right? And then because whenever you draw this to the top, ingat tak tadi bila kita tarik dia ke atas, ni kan tadi bila kita tarik dia ke atas kan, bila panjang ni adalah 30 kan. So mathematically bila you ada straight line yang sama, sini juga adalah 30 degree. Okay, so we want to use this one and to know this. Okay, we have 30 degree and then we have here 10 mm. Betul tak? Ni kan 10 mm. 10 mm. Then you can get this, right? So basically, because why we want to know this? Because this is D. So basically, here also the same, right? Okay, we name it as X and X. Okay, so X and X. So this is the capital D, X, meaning X plus this is what? The 15 mm, right? The D1, ataupun ni D1 kita namakan yang surface pertama sebagai D1. So D1 plus another X. So we know that D1 adalah 15 mm, kan? Yang tadi kita calculate, which is the first D is equal to D washer, and then you just calculate what is X. So tangent 30 equal to X over 10 mm, the thickness of the plate. So X equal to tangent 30 times 10. Okay, 5.773 mm. So because we do have 2x, so 2x equal to 11.547 mm. So overall, we have for the D2, we name it as D2, equal to 11.547 plus 15 mm. Then we get 26.54 mm. That's for D2. Now we get the D2. Alright, good. So D here is D2. Now you have D2, you have the small d, which is 10 mm. You have the thickness. Okay, so D2 here is 26.54 mm. Thickness is, berapa thickness dia? 20 kan? 20 mm. Yang modulus for steel. Yang modulus for steel is 207 gigapascal. So you just fill up in the equation again, the same equation. K, we name it as K2 equal to, get the K2 meganewton per meter. Okay, now how about the lower frustum? So for lower frustum, we may start with D at the bottom first. So we have D1, D2, D3 and D4. We start with D4 because easier for us, because we already know the capital D, the big D, right? D4. So basically D4 is similar to D1, which is 15 mm. D equal to the small d, which is the bolt diameter, 10 mm. The thickness, okay, the thickness is 20 mm, right? So thickness for the aluminium at the lower frustum is 20 mm. Okay, and then the Young modulus is similar, 71 GPa, and then you put everything in the equation. K4, okay, so K4 is 0.5774 pi. So the diameter for us, change it to the SI unit lah. Change to the SI unit. Let's say we change to the SI unit now. So pi times diameter. So the small diameter, is 10 mm, so 0.01 meter, okay. And then the Young modulus ataupun elastic modulusity is 71 GPa, so meaning 71 times 10 power of 9, right? Okay, and then divided by load. So first one is okay, so is 1201 meganewton meter. Okay, similarly, okay, let me delete this. We do for the K3. So at this D3, which is at the lower frustum for steel. So, small d is again 10 mm. D we don't know, so we use exactly the same analysis like for D2. So this is D3, so exactly the same, like this is 30 degree, this is 15 mm, right, this one, okay, 30 mm. So you want to know x and x. So here also we know 20, kan? Ni 20, So 20 mm. So tangent 30 degree equal to x over 20. So x equal to tangent 30 times 20. 11.4547 mm. So because ada 2x, so 2x equal to 23.094 mm. Because of D3 is 2x plus 15 mm, kan? 2x plus dengan 15 mm. So plus 15, so it become 38.094 mm. So you do the calculation. The thickness also know. We know the thickness. It is thickness nak ambil 20 ke? Tak boleh. Thickness adalah thickness ini thickness ni. Thickness for steel, tulis kalau boleh tulis. Thickness for steel at the lower frustum. So at the lower frustum you see here kan, ni lower frustum for steel. So thickness is 10 mm. Okay, then you put everything in the K3 0.577. Kenapa saya tuliskan ini supaya jangan tertukar, jangan tertukar. So D small d 0.01 and then it is still 207 times power of 9. Dah Pascal and then load, we can do one by one. 1.155. Thickness kita berapa? Thickness ni adalah 10 mm. Betul tak? 0.01. Okay, and then plus capital D. Capital D kita berapa? 38. Ni capital D kita 38.09 mm. So you change it to meter, it become 0.038. 09. Panjang it's up to you, but if you take just 0.038, it's also possible, also okay. Minus 0.01, okay. And then buka bracket baru pula untuk yang kedua, iaitu 0.03809 plus 0.01. Then the first one, second one is K3 is equal to 29.07 meganewton meter. So at the end you put all of them together. You put all of them together to become like this one. So meaning initially it was km equal to 1 over k over k4. But because you already know k1, k3, k3, k4, you just insert the value. You just insert the value. Meganewton meter, and then you just make it km, and then okay, then you get the final answer. So the final answer is 623.5 meganewton meter. Alright, I think I have explained everything on the frustum and also the conical shape analysis. So please do the exercise, do your own calculation, press the calculator so that you will not do the same silly mistake on the calculation, and also you really know what to do whenever you get this question. So this is assignment 3. Almost the same, but only 2 plates. You still have to do exactly the same conical shape. So if you look carefully, it will make aluminium to become upper frustum and lower frustum. So you do the same calculation, get the value, then your job is done. Finish. Thank you very much. Assalamualaikum and have a nice day. Bye.